Unit 5, Lesson 2, the ambiguous case of the sine law. So sometimes there are going to be situations where you're asked to solve for an unknown angle, and there's actually going to be two possible answers for that angle. Okay, when this happens, that is called an ambiguous case. So in this lesson, we're going to learn about when that ambiguous case occurs, how do you know when that ambiguous case occurs, and then once you know what's occurring, how do you find the value of that second angle? Okay, so again, the definition of an ambiguous case is when there's two possible solutions for the angle you're looking for. And just so you're aware, this will only ever occur when you're using the sine law. Okay, and we're going to talk a little bit later about why it doesn't occur when you're using the cosine law. So what do I mean by there's two possibilities or two angle values that could be the answer for a certain question? Okay, so let's say this was a question where you're solving for angle B. Okay, so usually you would go ahead and use the sine law because we have a set of corresponding side and angle. You'd fill out your values. And then you'd isolate for B. Okay, and you're going to get 35.7 degrees. And before teaching this lesson, you would have just stopped there and said, yep, that's my angle. Okay, but now I want you guys to notice that this is a case where you would have an ambiguous case, a second value of angle B, and here's why. So notice in the first triangle here, we're given the value of this angle, which is 30 degrees. We're given the value of its adjacent side length, which is 7, and we're given the next side length, which is 6. So we are given the values for an angle, side, and side. So whenever that side length that is across from the known angle is shorter than the side length across from the unknown angle, it's likely that an ambiguous case is going to occur. And here's why. So if we take this side length, the shorter one, and if we swing it to the left, okay, we can form a triangle with the same dimensions. It still has two side lengths of 7 and 6 and an interior angle of 30 degrees. But now, angle B is an obtuse angle. Okay? So because we still have the ability to create a second triangle with the same three original dimensions, that obtuse angle is a possible correct angle for angle B. Okay, so that's just kind of a solid intro about the ambiguous case. We're going to go into a lot more detail, okay, explaining this concept, but that's kind of the basis behind it. So let's look into the specifics and the math behind why the above can occur. So why we can take that one side length if it's shorter than the other one and kind of swing it to form a second triangle. Okay, so here's why. If you have your original triangle, right from above, it has an interior angle of 30 degrees, and then it has two side lengths of 7 and 6. Okay, and we're arguing that you can take that side length of 6, okay, this guy here, and swing it back here to form a second triangle. Okay, so in order for that to happen, that side length of A needs to be longer than the height of the triangle. Okay, and here's why. So if side A is longer than the height of the triangle, it can swing and it can fully attach to create this triangle. Okay, it connects with the other two side lengths. If the side length of A was not longer than the height of the triangle, then when it swings back, okay, to try and connect that new second triangle, it might only get that far. Okay, and you cannot connect the other two side lengths to form a closed triangle. Okay, so a lot of you guys might be asking, when I'm given a question, how do I know when to solve for that ambiguous case? When do I know to look for that second angle? Okay, and there's two ways that you can go about this. Okay, so the first method is usually easier for students to understand because you don't have to get into everything we talked about before, the whole like comparing that shorter side length with the overall height of the triangle. You don't have to do any of that for this method. Okay, so this method is easier to understand, but unfortunately it's a little bit more work in the long run, because basically this method says that just to figure out if there's an ambiguous case or not, it just requires that every single time you use Sine Law to solve for an unknown angle, check for the ambiguous case. So you just have to do it every single time. So it's not requiring that you understand when an ambiguous case occurs, it just, you know that it occurs sometimes when you use Sine Law. So every time you use Sine Law, check for that ambiguous case. So here's how you would do that if you were one person who wanted to follow method 1. So here's a question, solve for angle C. Okay, you'd say, well, I have a value of a corresponding angle inside, so I'm going to use Sine Law. And you're going to get a value of 53.13 degrees. But then you'd say, okay, because I use Sine Law here, I need to check for the ambiguous case. So to do that, you'd say, well, this is my acute angle, so let me check if the obtuse angle that is supplementary to this would also form a possible triangle. So you'd go ahead and subtract 53.13 degrees from 180. To figure out what the obtuse angle is. And you're going to get 126.87 degrees as the possible obtuse angle that is also a possibility for angle C. So to figure out if this could indeed be a possibility, all you have to do is then take that 126.87 degrees, add it to 30 degrees, and if their sum is still less than 180, which we know is the sum of the interior angles of a triangle, then we know it's possible still to have a third angle. So you would say, yep, that's a valid angle. If you were to add them up and you got a value already bigger than 180, then you're already over what the sum of the three interior angles of a triangle can be. So there's no way you could generate a third angle. So you'd say, nope, we are going to reject that as a possibility. There's only the one possibility. So let's go ahead and check that. So you're going to add them up. And when you do add those up, you're going to realize that their sum is still less than 180 degrees. So we can accept that as a possible value of our angle. So you'd conclude with, therefore, angle C can be equal to 53.13 degrees or 126.87 degrees. Okay, so to summarize, if you're someone who wants to use method 1 when determining if there is an ambiguous case, all it requires you to do is just any time you're solving for an angle using Sine Law, just do that extra calculation after. Find the obtuse angle that is supplementary to the angle that you found, and then add it up with the other angle already in the triangle and see if their sum is greater or less than 180 degrees. Okay, so again, that one's great, right? It's just easy, just check every time. Method 2. For those of you who can understand the reasoning behind the ambiguous case, okay, so that's all the work with, is that shorter side longer or shorter than the height? If you want to do that, it's going to save you some time because you're not going to have to check for the ambiguous case every single time. So there's two things you have to realize. First, you're going to realize that the side length across from the unknown angle is bigger than the side length across from the known angle. So that's your first clue that, yeah, this is probably an ambiguous case. Your second clue is that you need to calculate the value of the height of the triangle using SOHCAHTOA And if the value of A is larger than the value of H, you know that yes, this is an ambiguous case. I need to go ahead and find that second value of the obtuse angle. Okay, so for example, if we take our same triangle from above and we're asked to find angle C, if you wanted to approach this question using method 2, you would go ahead and find angle C using the sine law, so same thing as above. Okay, so I just quickly did the sine law, so same as what we did above. You get your same value for C, and then you'd want to quickly calculate the height of the triangle, so you'd use your SOHCAHTOA. You'd say, okay, well, sine of 53.13 degrees is equal to the height over 5, so 5 sine of 53.13 degrees is equal to my height. Okay, and because you have your height at a value of 3.99 units, that is smaller than the side length of 5, so you know that side length can swing and form a triangle with an obtuse angle. So because of that, you'd say, yep, this is an ambiguous case. So my second value of C is going to be 180 degrees minus 53.13 degrees using your supplementary angle rule. So you already know that your second value of C is going to be 126.87 degrees. Okay, so you don't even have to check the whole. Let's add that up with the 30 degrees and see if it's less than 180. All right. So why does the ambiguous case not occur when you're using cosine law? There's two ways you can look at this. Okay, first of all, we can use our cast rule, right? So all of the angles inside of a triangle are between 0 and 180 degrees. And if we look at our cast rule, and only the angles between 0 and 180 degrees, how many positive values of cos are there? Well, there's only one positive value of cos in quadrant 1. Okay, so there's only ever one possible answer when you're using cosine law. The reason why there's this ambiguous case associated with the sine law is because between 0 and 180, there's two possible positive values of sine, right? It's positive in quadrant 1 and 2. So that's why sine law sometimes has two possible angles and not cosine law. Okay, also, we learned about the criteria that needs to happen in order to use cosine law. Okay, and in cosine law, it requires you to either have the length of all three sides, okay, and in that case, right, so if you were finding this angle, and you knew that this was 5 units, this was 6 units, and this was 7 units, that would be a situation where you would use cosine law. But there can't be an ambiguous case because those three sides are fixed. That triangle is fixed. It's not able to take on another form. Okay, the other way that is if you have a side, angle, and a side. So for example, same thing here, right? If you're given a situation where you have a side length, an angle contained, and then the next side length, that third length is also fixed in a certain position, right? Because this side only projects out at 45 degrees and it's only 6 units long. Same thing with this one, it projects out at 45 degrees and it's only 7 units long. So there's only one side length that can possibly connect that triangle. There's no room for movement here either. Okay, so the takeaway here is that you never have to check for the ambiguous case when using cosine law. All right, let's do one quick example. So solve for angle A. Okay, so because we have a set of a corresponding angle and side, I'm going to use sine law to solve for this. And because I'm using sine law, in the back of my mind, I know I'm going to have to consider the possibility of an ambiguous case. So we're going to get a value of 60.16 degrees. Okay, now I'm going to go and solve this using method 1. Okay, so method 1 says check for ambiguous case by taking the value of the acute value of angle A, find its obtuse supplementary angle. So possibility for A2 could be 180 degrees minus 60.16 degrees. A possibility for angle A2 would be 119.84 degrees. So to check that, let's add up 119.84 degrees with the existing interior angle, so 70 degrees, and let's see if that's greater or less than 180. Right, so we end up getting a value greater than 180 degrees. Okay, we get 189.84. So because those two angle values together are already greater than what the sum of all three are supposed to be, we're going to say that A2 is not a possibility. So this triangle only has one value for angle A. So therefore, angle A is equal to 60.16 degrees. So you would just say, no, there is not a second solution, because when you take the possible obtuse angle and add it to 70 degrees, you get a value greater than 180 degrees.